Unit 4.7 Quadratic Formula. In this unit, we are going to learn how to solve a quadratic equation by using the quadratic formula. And the next concept we're going to learn is to determine the number of solutions by using the discriminant. So far, we learned 4 strategies to solve a quadratic equation. First, we learned factoring. For example, if you have an equation, say x squared plus 4x plus 5 equal to 0, then we're gonna change it to a factor form of x plus 5, x minus 1 equal to 0 by using the sum of the factors of c. Then we solve for x. The next things we learn is a formula of difference of square, which means a squared minus b squared equal to 0. Then we can change it to a plus b times a minus b equal to 0. For example, if we have x squared minus, say, 3 squared, we can equal to 0. We can rewrite it to x plus 3, x minus 3 equal to 0. Then again we solve for x. The next thing is applying the square root. To solve the quadratic equation, if we have a squared equal to 5, all we need to do is take the square root of both sides to get rid of square, and then we end up getting a equal to positive and minus square root of 5. The next strategy that we learn is completing the square. So if we have x squared, say plus 4x equal to 6, then we just have to complete the square of this by adding 4, and then we have 6 plus 4, and we have x plus 2 whole square equal to 10. Then we can use the applying the square root thing. We take the square root of x plus 2 whole square equal to square root of 10. Then we have x plus 2 equal to plus and minus square root of 10. In this unit, we're going to learn another strategy of using quadratic formula to solve quadratic equation. Here's the quadratic formula. Based on the standard form of the quadratic equation, we just plug in all the values of the variables inside the quadratic formula so we can solve for x. So this is b right here and c is right here. So it's minus b plus and minus square root of b squared minus 4ac over 2a. So if you have all the variables of these coefficients a, b, and the constant c, then you can use the quadratic formula to solve for x. Now let me give you an example. What are the solutions of this quadratic equation? The reason we know it's a quadratic is because the biggest power of the whole equation is 2. The first step is to rewrite the whole equation in standard form so that we can identify the values of the coefficient a and b and the constant c. Let me show you. So all we need to do, just subtract 4 on both sides, then you end up getting an equation like this. Once we have this form, we can line them up with ax squared plus bx plus c. Then we know the values of a, which in this case is 2, b, watch out, is negative 1, and then c is negative 4. Since we know all the values of a, b, and c, we can apply it to the quadratic formula all we need to do is substitute for A, B, and C, and of course we have to be really careful about the arithmetic right here. And after that we can simplify this answer to 2 because this is a plus and minus signs. So you have two answers right here. One is 1 plus square root of 33 over 4. The other one is 1 minus square root of 33 over 4. The most important concept that we have to learn in this unit is discriminant. Because based on the quadratic formula, we can actually find the value of the discriminant, which is equal to b squared minus 4ac. The value of b squared minus 4ac tells us how many solutions, whether they are imaginary or real, of the quadratic equations. Let's see how it works. So this is the quadratic formula, which we use it to solve for x. But inside this formula, there's a really interesting feature, which is b squared minus 4ac. The value that we got, we call it discriminant. When the discriminant is bigger than 0, we have two real solutions. But when it's equal to 0, we have only one real solution. And when it is less than 0, we're gonna have two imaginary solutions, which we're gonna talk about that in the later sections. So let's see how it works. When you have b squared minus 4ac in the quadratic formula, which is bigger than 0, that means it is a positive number. So let me put this back into the quadratic formula. So we have x equal to negative b plus and minus square root of a positive number, because we just said b squared minus 4ac is bigger than 0. So that's why this is a positive number. Remember, when we take the square root of a positive number, we are going to have a positive real number here. Because square root of positive number, we're going to have a real number. So for example, if we take a square root of 9 and we simplify that, we're going to have minus b plus and minus negative square root 3 over 2a. We don't care for b and a right now because they are also a real number. And when you have this notation, you know you're going to have two solutions. So x is equal to negative b plus square root of 3 over 2a, and x equal to negative b minus square root of 3 over 2a. So that's why we called it two real solutions. Let's take a look at what happened if b squared minus 4ac equal to 0 now. Alright, so we plug this value of 0 back to the quadratic formula, which we have negative b plus and minus 0, because we said b squared minus 4ac equal to 0 over 2a. Again, for now, I don't really care about b and a because they are real numbers, so they should end up real numbers. And square root of 0 is equal to 0, so we have negative b over 2a only, because this one is nothing. And that's why we have negative b over 2a as the solution. And that's why we said it has only one real solution when b squared minus 4ac equal to 0. The last one is b squared minus 4ac less than 0. Let's put it back into the quadratic formula and we'll see what happens. Right now, because it's less than 0, that means it's a negative number. So we put this negative number here over 2a. So when we take a square root of a negative number, it will give us an imaginary number. Over 2a. And that's why we have two imaginary solutions, which is negative b plus that particular imaginary number over 2a, and then negative b minus imaginary number over 2a. We're going to talk about that in the later sections. But for now, just remember the discriminant tells you the number of the real solutions as well as the number of the imaginary solutions of a quadratic equation. Here is an example of how to use the discriminant to find the number of real solutions of these quadratic equations. So of course, the first thing we try to identify the value of a and b and c of the quadratic equation. Again, if you cannot see it, I rewrite it like this. So a squared plus bx plus c. So we line them up. A is equal to negative 2, b is equal to negative 3, and c, of course, equal to 5. Once have that, the discriminant is equal to b squared minus 4ac. All we need to do is just plug in the value of each variable. b negative 3, a is negative 2, and c is 5. So we evaluate this discriminant by do a little bit calculation here. We end up getting 49. Since 49 is a positive number, we can tell this equation has two real solutions.